Today we will be discussing about Bayes theorem. What is Bayes theorem? Bayes theorem is nothing but conditional probability case. So how it works? So imagine there is a sample space, say E1, okay, and there is one more sample space called E2. Both are different sample spaces, so there is no dependency on these two sample spaces. And there is a common factor among these two sample spaces. Say the common factor is called as some A. Now if you want to know the total probability of this sample space A, it is like this, because this is intersection of this one P, A intersection E1, and this is one more intersection here P, A intersection E2. Now this A is common in both E1 and E2. Now as per total probability, so the probability of A which is common here is nothing but probability of A plus E1, and here it is again here intersection with E2, so it is probability of A intersection E2. Okay. So in order to achieve this total probability of A, what we have to know whether this sample space exists or not. What is the probability of A goes to sample space A1, A goes to sample space E2. So this is equal. So first you have to know what is the probability of E1. Next, what is the conditional probability of occurrence of A in E1 plus what is the probability of E2 in probability of A. Here we have taken this conditional probability because if you are interested to know about what is the probability of A, first you have to know about whether this sample space exists or not. If sample space exists, then only there is a chance that occurrence of A in E1. So next, what is the probability chance of E2, happening of E2? First we have noted on here. Then what is the occurrence of A in E2? This comes under total probability. Now the Bayes principle comes here. Once this has been done, it's calculated. The total probability has been calculated. It's now reverse application of problem. What is the occurrence of this A? Okay, what is the occurrence of this A from E1? So occurrence of A from E1. Okay, so fine. So this is called as E1 after A has happened. What is the occurrence of E1 after A has happened? Is nothing but probability of E1 intersection A divided by probability. So again this is conditional probability. This probability of total probability you have to apply this formula, and this is the conditional probability one you have to take. Okay, so this is nothing but P of E1 into P of A by E1 over divided by P of E1 into P of A by E1 plus P of E2 into P of A by E2. Okay. So if I take here probability of E1 as, okay, P1, probability of E2 as P2. I mean, what is the occurrence of probability of E1 as P1, probability of occurrence of P2. So, and combination of this P1 plus P2 is equal to 1, because this is what is the probability of E1 plus probability of occurrence of P2 is 1. Now, so this conditional probability like P of A by E1 is equal to X, P of A from E2 is equal to Y. Then it looks very simple now. How? The probability of A1 is equal to X into, like occurrence of X into P1 plus Y into P2. This is total probability. Right? Now the question is, so what is the probability of E1 by A is equal to X into P1 by XP1 plus Y2. So this is conditional probability. So this is mostly useful for statistical inferences. like once something is happened, and if you want to know what is the occurrence of that event from the sample space, you can know this. Now it is very easy to calculate this V2 by A, because already this has been calculated. 1 minus something, 1 minus this one will give you 1 minus xp1 by xp1 plus yp2. So this is nothing but, okay, this is nothing but yp2 divided by xp1 plus yp2. Fine. So just I will clarify completely with the help of an example. Imagine there is a medical problem. Medical problem, like there is a high fever. For fever, two companies came friend to prepare medicine for that. So this is a fever. This is a problem. And these medicinal companies, this is medicine company 1, medicine company 2. And what is the probability that this fever is solved by this medical company 1? Medical company is nothing but total problem. So this is over. How this fever is solved by company 1, company 2. For example, there is a case that some patient came and fever problem is not solved or solved, and you want to know whether the fever person used this medicine chances or this medicine chances or this medicine chances. Okay, so you can use this reverse probability case. By taking the help, we can, with the help of Bayes theorem, we can track back which company has made that error, which company has made that medicine, and which company has made that medicine. Okay, fine. This is one of the advantages of Bayes theorem. I'll explain this Bayes theorem again with a student example. Imagine a student answered a question correctly. Answered question correctly. Okay, there is a chance that he answered correctly either by knowing the thing or by guessing the question. There are two chances. He can answer correctly by knowing it and by guessing it. Okay. So now if you want to know what is the probability of answering the question is nothing but probability of answering is nothing but, so this is P1, probability of knowing is P1. If we don't know, it is called as P2, it is called guessing. So and sum of this P1 plus P2 is always 1. So this is by from P1 probability of P1 by probability of A by P1 plus P2 into probability of A by P2. This is how he answered the question correctly. Now, if he answered it correctly, but if you want to know back whether what is the probability of answering correctly with knowing, and what is the probability of answering the correctly with guessing, that is the reverse thing you want to know. Like if you want to know, he answered correctly from guessing is equal to this one. So probability of answered correctly, probability of going to guessing into probability of answered correctly by guessing whole divided by probability of knowing into probability of A by knowing plus probability of B into B. So with guessing. So this is way of, this is called condition probability. This is mainly used for statistical inferences. Once something has been done and you have the total probability of that, and you want to know back the reverse way of knowing it from what is the chance from this sample space and what is the chance from this sample space, we will use this Bayes theorem. It has high applications in statistics to get the conclusions. Fine. First, what is a function? A function is nothing but a system, any system, which takes an input and gives proper. This is a function. Now, if it is taking trigonometric inputs, so if it is taking the values as x and the output is in the function of using trigonometric function, then it is called as trigonometric function. Okay, so here the input side is called as domain and output side is called range. Now there is always chance that if you give domain in input, there will be output. Now if you give back output and if you know what is the domain of that, then that concept is called inverse trigonometric function. The simple thing is, I can say like this: assume it is a sine function, and I have given input as 45 degrees, and your output is, when you give 45 degrees to sine, it is equal to 1 by root 2. If you give 90 degrees here, the output is 1. So this is normal trigonometric operation. Normal trigonometric operation, where angles you are giving as input and values you are getting as output. Now, if you want to give back these values, like reverse operation, like giving here 1 by root 2, you have to get 45 degrees. Giving back 1, you have to get it here 90 degrees. But actually, this is the problem. This is called inverse trigonometric function. But the problem here, we have a big problem here, because whenever you give 1 here and it is a inverse function, sine inverse of x, you will get this one at 90 degrees, again at 450 degrees. So we have many solutions here, For the inverse function, for one input, the basic definition of function is for one input, only one output must be there. But here, for one input you are getting, so one to many function. It is can be given to one to many function. In order to avoid this, we have to restrict this trigonometric values. That restriction of this trigonometric value is called as principal value. What is that? Say, if you have a sine function, if you have input here, if you have output here. So, in order to not to repeat the values, so say they curve like this is sine function 1, this is minus 1. So here you have 0, 1 by root 2, 1 by 2, 1 by root 2, root 3 by 2, 1, and there is a repetition of values here. So stop it somewhere here. Pi by 2. And again go to the back side. 0, minus 1 by 2, minus 1 by root 2, minus 1. Again there is a repetition here. So stop at this repetition. So this is called as minus pi by 2 to pi by 2. So where there is no repetition of values here. This is where we are restricting the domain for non-repeating values for pi by 2. And output again here from minus 1 to 1. If you restrict this value, then only for each and every value of this trigonometric theta, we have different value of output here. Okay? So when you restrict this, then only the reverse thing is possible. That is inverse function possible. Like you are giving from minus 1 to 1, you are getting from minus pi by 2 to pi by 2. Okay? So what is the principal value? So whenever you are giving this value, the first value that comes in this trigonometric function, that is called as first value is called as principal value, non-repeating value. And remaining solutions you will have many taken other values. But first non-repeating value comes under principal value, that is called principal value in inverse trigonometric function. So for example, if y is equal to sine inverse of minus 1 by root 2. So this is for principal value is for the theta is minus pi by 4 or minus 45 degrees. This comes as principal value.